Today we'll do some informal code analysis, and as an example we'll look at our algorithm where we calculated the mode of a list of numbers, being the number that occurs most in the list. And here we'll do a statement execution count, which will indicate the number of times that a statement is executed by the program. And here the statement that will be executed most is the statement inside the nested loop, which will be the comparison between two numbers in the list at index I and index j. So here we can see at each iteration of the outer loop, each number in the list is going to be compared with all the numbers after it. So here we have 14 numbers in the list, and in the first iteration 2 is going to be compared to the 13 numbers after it. So the number of comparisons is 13. And then in the next iteration, when I equals 1, 4 is going to be compared with 12 numbers after it. And continuing this process, 5 will be compared to 11 numbers after it, and so on. And then finally, when we reach the last number in the list, being at index I is 13, then j at index 13 plus 1, being 14, is not less than the length of the list. So there's no comparison done in the final iteration. So if you add all these numbers together, we'll get 91 comparisons in total. Now in the general case, given a list of n numbers, in the first iteration we have n minus 1 comparisons, and in the next iteration we have n minus 2 comparisons, and so on until we get to 2 and 1 comparison. So this is the total number of comparisons by this algorithm for a general list of numbers, and we call this the sum. So if you recognize, this is an arithmetic series, so effectively each number in the series differs by the same amount, in this case being 1. And once you get into more advanced courses of computer science, you'll see that the sum of this arithmetic series is the largest term in the series, being n minus 1 in this case, on 2, and that's multiplied by the smallest term in the series, being 1, plus the largest term in the series. So this is the closed form solution that you'll obtain. So when you cancel the 1's, this is equal to n by n minus 1 on 2. So if we test this out for our list of numbers here, being 14, so we have 14 by 14 minus 1 on 2, which gives 91. And it's the same result that we got using our statement execution count. And in more advanced courses, this will lead to a more formal code analysis. So we can write this sum by expanding this multiplication, so that'll be n squared on 2 minus n on 2. And the formal notation is big O notation, where we use the fastest growing term, being n squared, to determine the complexity of the algorithm. So in this case we said the complexity is O n squared.